All right, so this is 5-5 day 2. And we're going to look at synthetic division. We've already done this before when we did synthetic substitution. So this is the remainder theorem. You can write this down if you want to, but you don't have to. Basically, it says if a function is divided by a polynomial, then the remainder is equal to f of whatever this number is. So basically, if you plugged k in, then the remainder would be what you would get. Okay, so we're going to do this first problem. Oops. There's actually 2 problems written there, but we're just going to do this first one. So we're going to divide this polynomial by x minus 1 using synthetic division, not long division like we were doing Tuesday. So what you do is you notice that this is a binomial. So what we have to do is set it equal to 0 and solve for 1, or solve for x, sorry. So add 1 to both sides. X is equal to 1. This is the number that goes out in front of the synthetic division. So then remember, you do the coefficients. So the coefficient of x cubed is 1. The coefficient of 2x squared is 2. The coefficient of x is negative 6. And then negative 9. Drop down the first term, 1. You multiply the outside number times the new number. Put that inside the bracket. Combine like terms. Multiply the new number times what was out front. Combine like terms. Multiply the new number times what was out front. Combine like terms. So what happens when you divide a polynomial by a polynomial is that it reduces by 1 degree. So if we look up here, this used to be an x cubed. So now because we divided it, it reduces it by a degree. So this is actually now an x squared. So these are the coefficients of the new polynomial. So I'm going to start with the 1. So that's going to give me 1x squared. Then the 3 is going to give me plus 3x. And then the negative 3 would be the constant. So it's just 1 less than what the problem had before. Up here it had x cubed. Now we have an x squared. And then the 3. And then the negative 3. And then this is the remainder. So then we do a plus. And we do negative 12. And we do fraction bar. And we copy down the binomial that we had from the beginning. X minus 1. And that's our answer. So let's do the other example. Now we're going to do x plus 3. So again, you take the binomial, you set it equal to 0, and you solve for x. It's always the opposite of what's in there. So we have negative 3, copy down the leading coefficients, drop the first term down, multiply, put that number inside the bracket, add down, multiply. So negative 3 times negative 1 is positive 3. Multiply. This time we get 0. Whenever we get 0, that means that x plus 3 is a factor of x cubed plus 2x squared minus 6x minus 9, because it went into it evenly. So it means that we have no remainder, which if you remember when you do numbers, again, it means it goes into it evenly. So we need to write our answer. So we look up here, and we see that it was a cubic function. This will always be 1 degree less, so a cubic function minus a degree is a quadratic function, so this would be squared. So what was a 3 becomes a 2. And then the next term, so now I'm going to have a negative, so I'm going to copy this down. Negative, and then instead of writing a 1, we just write x. And this is the constant, so it just goes in order. Squared, 1, and then none. And then we don't have a remainder because it's 0. So this is our answer. Right? If you wanted to, it's the same thing you would get if we did polynomial long division. And I'll just do it to the side. You don't need to write this down. But I just want to show you that it's exactly the same thing. It's just a lot less work. So I go to the side and I do x cubed divided by x. Get x squared. Multiply. Subtract. Bring down the next term. Negative x squared divided by x would be negative x. Multiply. subtract. Okay, do the next term, multiply, subtract. So you have 0 remainder just like I did before, and see how they match? Pretty cool, but the synthetic division is way, way easier. At least a lot less work. Okay, so again, just stressing with the fact that no remainder, that's a big deal. No remainder means that x plus 3 is a factor of the original polynomial. And so that would mean that basically this guy would factor into x minus, or x plus 3, and then x squared minus x minus 3. I mean, so far that would be a factor. And we could see what two numbers multiply to make 3 and subtract to make 1 to keep going. But 3 and 1, it doesn't work, so it doesn't factor anymore. Okay, so we're going to work on these problems tomorrow in class. If you're not going to be here tomorrow in class, then that's the assignment you're going to want to do. If you're going to be in class tomorrow, we're going to work on these together, so you don't need to worry about starting it right now.